Hello, statistics student. This video, I'm going to talk about doing statistical analysis after I copy all the data summary that I got from Google Sheets into my work document. So there are three statistical analysis that I need to do. First is to do a 95% confidence interval for difference in proportion of younger and older students preferring drama. So as in my data summary show in this sample, 44% of older students prefer drama versus 60% of younger students prefer drama. So is this difference significant, or is this just difference because of sample difference? So I mess up my younger and older again. So population 1 should be older and population 2 should be younger. So make sure that you don't you follow your population definition closely. So, and in the previous summarization, I have N1 equal to 18, X1 equal to 8, N2 63, X2 equal to 38. So I'm going to do the confidence rule by specifying them here again. N1 equal to 18, X1 equal to 8, N2 equal to 63, and 2 equal to 38. And then it is 95%. So I'll use this confidence interval proportion to samples to find the confidence interval. So here I will do analysis, confidence interval proportion to sample because they're categorical data, and it is 18, 8, 8, 63, and 38. No, 38. Can I do evaluate? There I have the data. So the confidence, 95% confidence interval is negative 0.418, P1 minus P2, 0.101, 0.101, around to 3 decimal places. So I'm going to put it in my project. So this is the output. 0.4, negative 0 is negative, 0.418. And positive in the upper bound, 0.101. So these are the numerical output, but we should write it down in a sample, in a sentence. We are 95% confident the true difference in proportion between older and younger students, older and younger students preferring drama is between negative 41.8% to 10.1%. Okay, so this is your description written in a sentence using percentage. Convert these two numbers in percent, and then because 0, so this number from negative to positive, of course it will contain 0, is in the interval. Do we have sufficient evidence? We do not have sufficient evidence to conclude that there is significant difference between the population proportion. It is likely that both older and younger students prefer drama video in the same proportion. Yeah, so that's the conclusion, and that's the interpretation of your confidence interval. So that's part 1. The second part is about hypothesis tests. Earlier in my project plan, I have a claim that I made that younger students watch more videos than older students. So because younger is population 2, so I would say older watch less than younger, right? So I have to redo this. Older students is population 1, younger is population 2, right? And then I have to put down the summary that I have here. So just copy them over. 9.088, those things. X1 bar is 8.17. No, 9.088. 9.0833. Just do more decimal place to be more exact. 6.3576. N1 is 18. X2 bar is 8.1719. And 2 is 9.4393. 0.4393. And 2 is 63. And I should say mu1 is less than mu2 because the claim said that the younger watch more, right? So the older would watch less, right? So this is the definition and this is the claim. And then HA, alternative, is mu1 less than mu2. And these two are actually independent samples, so we use that this analysis hypothesis test mean to independent sample to find the test statistic T and also p-value. So switch to stat online, we'll do analysis hypothesis test mean to independent sample. And I have to do population 1 mean is less than population 2 for my claim. Okay, so I'm going to do the input. This is 18. 9.0833. Standard deviation 6.3576. We don't have population standard deviation, and then this is 63. 8.1719. Well, you can actually see that actually my sample 1 is 9. It's actually bigger than sample 2, so we probably do not have sufficient evidence to reject the null hypothesis. So this sample probably is not significant. 9.4393. Sometimes the hunch that you have about the mean difference, the mean difference between two population is wrong. So your sample actually provide that that you can see that there is no way for this to be to be lower than, because even the sample has a mean that is higher than that. Okay, but of course sample data vary, so even if one is less than the other one, maybe it's the hypothesis can still be true. So we choose to assume that there's unequal variance, so we don't put the data. And here is my output. I have t equal to 0.4764 and p-value equal to 0.6818. Got 90% confidence interval is also here. You can see that there's negative, positive, so probably no significant difference, right? So let me put down my number. So t is 0.4764, 0.6818, p-value equal to 0.6818. And because p-value of 0.6818 is greater than 0.05, so this is not a rare event, so we say fail to reject the null hypothesis for me, because that means my sample actually agree with the null hypothesis that mu1 and mu2 is no difference. There's not enough evidence, not enough evidence. There's not sufficient evidence. Because these things are nothing significant occurs, right? So x0 is, or the sample agree with x0, you can say. So do not say you accept x0, but rather say you fail to reject or the sample agrees with x0. There's not sufficient evidence to, what is our claim? Our claim is it was HA, right? So we would say not sufficient evidence to support the claim that younger students watch longer video longer than older students. So that is our conclusion. Make this nicer. So this is, you can also talk about that the sample difference is actually 9 and 8. Okay, so the last things is about linear correlation. So I would have, and we would do a hypothesis test. So in order to do that, I need to copy my data that I have in here with the two sample, copy both of them into StatDis because I cannot summarize it to do a hypothesis test. Okay, so copy them into StatDis, Control V, and then do an analysis, correlation 1 and 2. So you see how the correlation coefficient is the same as in Google Sheets, negative 0.1816, and R is actually more accurate, 0.22, 0.2185, but we would want to do the p-value. In this case, p-value is 0.2185, p-value is 0.1046, so it is not lower than 0.05. Our significance is 0.05. So I'm going to go back to my sample and record this. So here I will say negative 0.18, what was it, 1816, just like what we have done before. Critical R is plus and minus. This is a little more accurate, 0.2185. P-value is 0.1046. Okay, so since p-value is less than, or which is 0.1046 is less than, no, it is not less than, it's greater than 0.05, again, fail to reject x0. You can actually talk about x0. What is x0 here? X0 is rho. Where is rho? Is this symbol rho, the Greek symbol? Oh, it doesn't show up. Here, this one. Third row is equal to 0. No linear correlation. And then HA is so copy. HA is rho not equal to 0. Symbol not equal to 0, so there is linear correlation. So if I fail to reach x0, that means x0 conclude no linear correlations. Okay, but the actual wording would be there's not sufficient evidence to support that there is a correlation between students' video watching time and number of units taken. So these are the three analyses that we should do: confidence interval, hypothesis test, and test for linear correlation.